In this demonstration, I'll show you some of the basic post-processing capabilities available in ANSYS Fluent. In this example, I'm going to post-process the data collected from a pseudo-transient simulation describing the combustion reaction in this CAN combustor. I'll start by inserting an XZ plane, which is defined using the point and normal method. This location will be called plane XZ. With my plane defined, I can insert maps or plots at this location. For this example, I'm going to add a contour plot at this surface that describes the mass fraction of CO2. With the CO2 mass fraction variable defined, I can set the plot's location to plane XZ by selecting it from the surfaces list. For context, I can select Draw Mesh and include the canister's wall faces, then choose Banded or Smooth. I think this plot will look better with a smooth coloring style. This contour map of the CO2 concentration shows me that the flow is mixing and reacting properly. The lighting is washing out some of the detail here, so I'll change the position of the light source. A temperature contour at the surface of the canister will show me where hotspots form. I'll set the canister's wall boundary as the surface location for this plot. The temperature range for this contour will be 300 to 1500 Kelvin. Notice that the Clip to Range option is automatically selected. This option tells Fluent to clip the contour to areas where the variable values are within the desired range. I'd like to view the entire canister, regardless of the variable value, so I'll uncheck this option and use the same display settings as before. I'd like to determine the concentration of unburned fuel exiting the reactor outlet. This is easily done using the surface integral tool, which can quickly calculate weighted averages and other integrals at defined surfaces. For this example, I'll compute the mass-weighted average mass fraction of methane passing through the combustor's outlet. Note that the result is also reported in the console. To finish post-processing the result, I want to add an isosurface that will show me the recirculation zone inside the canister. Since the airflow is primarily in the z direction, the fluid will have a small negative velocity in the z direction at the surface of the recirculation zone. The recirculation zone will be more apparent if I add a streamline showing the static temperature of the fluid passing around it. The streamlines will start at the fuel inlet and end at the outlet. To best display the streamline and isosurface, I'll create a new scene, add the streamline object, then add the isosurface as a mesh object. I think the isosurface will look best if I only display the mesh faces, color it white, and make it slightly transparent. The final plot shows how the fluid maneuvers around the recirculation zone as it traverses the canister's interior. This concludes this demonstration of some basic post-processing tips for ANSYS Fluent.